Assalamualaikum and hi, my name is Nur Fatin binti Yazid and my metric number is B031910017. In this video, we're gonna explain to you about decrease and conquer algorithm. There are three types of decrease and conquer algorithm. The first one is decrease by a constant, in bracket by 1. And the second one is decrease by a constant factor, in bracket by half. And the third one is variable size decrease. We are gonna explain to you more about decrease by a constant in bracket by 1. There are four types of decrease by a constant, which are insertion sort, topological sorting, graph traversal algorithm, algorithm for generating permutation and subsets. We choose graph traversal algorithm. There are two common graph traversal algorithms, which are DFS and BFS. We are going to explain to you more about depth first search, which is known as DFS. DFS is an algorithm for traversing or searching tree or graph in a deferred motion. It is invented as a strategy to solve maze in 17th century. Depth first search will visit graph vertices to an unvisited one, else it will backtrack if no more nodes. Backtracks mean that when it moves forwards, there is no more nodes along the current path. It will move backward on the same path to find new nodes to traverse. The second one is recursive, or it is used a stack. I'm going to explain to you generally how the depth first search implement in the stack. First step is pick a starting node and it will select next node to visit. It will push adjacent node into the stack, and this step will repeat until the stack is empty. Ensure note, all nodes that are already visited will be marked. If it's not marked, it will become infinite loop. And the last one is redraws graph in tree-like fashion. This is some of application and implementation of DFS. Application of DFS. The first one is detecting cycle in the graph. And the second one is finding the strongly connected component and bridge of a graph. The third one is solving puzzle with only one solution. For example, maze. Implementation of DFS. It uses stack instead of queue. It will mark only after popping the vertex, not before pushing it. And the last one is it uses reverse iterator to produce same result. That's all from me. Thank you.
Assalamualaikum everyone. Hello, today I will be presenting that first search algorithm by using picture diagram. My name is Nursyafiqah Adilla binti Syafiq. I am from 2BITS S1J2. So this is our sample order that are given. We are required to find the output. So we are required to find the output, or can be called as order. So based on the picture diagram, we have this picture diagram. So from this picture diagram, we can conclude that in order to pass us through all the alphabet here, we are required to go step by step. So the first one, I'm going to choose from R. You have to find the adjacent to it. So the adjacent to it is Q. So I'm going to put Q here. So my output will be R and then Q. And then after Q, I don't have any alphabet after Q that adjacent to it. So I will move back to R and then I will see T. T is adjacent to the R. So my next output will be T, sorry. After T, I can see that there is two more alphabet. you can go either way. Either you can choose S or you can choose Y. But for me, I will choose the first one. So my next one will be S. So my next order will be S. So after the S, you are not going to coming back because that is not the end. You still have a few alphabet that adjacent to it, like U, V, and W. So the first one, I choose U. So adjacent to adjacent to S, I have U. So my output will be U. And then after U, it is dead end. I don't have any alphabet adjacent to it. So I will continue to V. So I move back to S, and then I will find out there is V. So my next output will be V. And then I move back to the S, and then I will find another. Oh, sorry, I'm not going to move back because this is not the end. You can see, right? This is not the end because you can see the X here. So from V, I will move to the X. So I will have X here. My next output will be X. And then after the X, I will find out that this is also not the end. Not the end. So I still have Y after it adjacent to the X. So my next output will be Y adjacent to the X. And then after Y, I found out that there is two more. Is it possible for me to go to T, or is it possible for me to go to W? Which one should I choose? For me, I already choose I already written the T I already chosen before. You know, here you can see the output. So I will choose what from Y adjacent to Y is, I will not choose T, I will choose W. So my next output will be W. And then that's it. That's that first search algorithm. It's easy. You can see here is my output, but you can see here, if you compare from this to here, you can see that there is lack of 2 arrow, which is here, and another one is, I can see there is lack of 2 arrow, but I'm not sure which one. Okay, so here, I'm not going to satisfy all the arrow here, but I will satisfy all the alphabet here. I'm not focusing on the arrow, but I'm focusing on the alphabet. As you can see, I able to satisfy all the alphabet here. So let's check our answer. So yeah, our answer is correct. That's it. Thank you. Bye bye.
Assalamualaikum everyone. My name is Nuramelynn Izzaty binti Hisham, and my metric number is B031820043. Now I will explain on the coding of the first search. Using C++ programming language, we first see that we have included 2 header files at the top, which are iostream and list. Below it, we then see there is a class named dfsgraph. This class is where we create the list for every input named adjlist. We also declare a void function called dfs_util, which accepts 2 parameters, integer v, and boolean array called visited. Inside the class, there is a function called addEdge, which accepts 2 parameters, integer v and w. For every w input, it will be added into a adjlist array of v using the pushback function, which is a form of stack. This means that W is connected to V in our graph, which is why it is included in the adjacency list of V in the form of a adjlist array. Then we call a void function called dfs. Then inside void dfs_util, which belongs to the dfsgraph class, we declare that the current node visited is true. Then we see out what the node is. Below that, there is a for loop where I is initialized as the beginning of a adjlist of node V using the begin function. And this loop have a condition that it will run if I is not equal to the end of a adjlist of node V, which uses the end function. And it will loop for ++i times. Inside the for loop, there is an if statement. If the I is not visited, Then we need to execute the fs underscore util recursively with I as the new node v. The next function is void dfs. A new visited variable is created, which is boolean v. This for loop is created to declare that initially every visited value is false, meaning that none of the vertices are visited at first. Then in the second for loop, there is an if statement. If the current node visited value is false, then execute the fs underscore util, which has been shown earlier. Lastly, in the main function, we will create the graph. In this tutorial, we will show a static example where we hardcode the edges of the graph. So first, we declare a variable from the class dfs graph and name it gdfs. We put the total number of vertices inside the bracket. In this example, it is 10. As a reference, I will include the picture of the graph by the side. As you can see, we now have to add the edges. Using the addEdge function, we insert the value of the start and end vertices for each edge. We will start with 1 and 2, 1 and 3, 2 and 4, 2 and 5, 3 and 6, 4 and 7, 5 and 8, 5 and 9, and 6 and 10. Then we will see out the order of the depth-first traversal for the given graph by calling the dfs function to calculate the order. Then we end it by returning a 0. Now, once we compile and run the code, we will get 1, 2, 4, 7, 5, 8, 9, 3, 6, and 10. And that is it for this algorithm of depth-first search or depth-first traversal for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nursyafiqah binti Muhammad Saofi from BITP S1G1. My number matrix is B0319101122. So in this video, I will explain you about complexity depth first search. So this is algorithm for depth first search. So I will use this algorithm to find time complexity and space complexity. So first, we will find time complexity. I just said just now, I will use this algorithm to find time complexity. So first, from this command, I can get pushback. I will assume is as C as for cos. So visual start equal to true. So it also C. For looping, I will assume it as NI. So next, this is one of the scenario of depth first search. I think Syafiqah Adilla have explained about how depth first search running. So from this scenario, I can get 1 as started number, and then it will go to 2, and then it will go to 4, 5, and lastly 3. From this scenario, I can get that I can assume this as C. Why I assume this as C? Because it's supposedly to be 2C, but 2 is the constant. So from this scenario, I can get this as C plus Ni plus C plus Ni. So from this scenario and this calculation, I can get C plus Ni and C plus Ni equal to vertex. Okay, so this we call it as vertex. So it be C vertex plus sum of Ni. I remove C as it is a constant, and then I change this to 8. So V plus E, and then the time complexity is O V plus E. So next is space complexity. I will use the same algorithm. So now I assumed it as V, and then I'm also assumed it as V, as it is vertex. Then this is also I'm assume it as V. So this is I'm assumed is as this table I'm assumed as V plus E because this is V and then this is the H, meaning that the first stack go to how many H. So this is the number of H. So we assume is V plus E. So V plus E plus V plus V plus V equal to 4V plus E. So 4 is the constant, so we can remove it and we can get space complexity as OV plus E. So that's all from me. Thank you.
Hi and Assalamualaikum. My name is Nursyafiqah binti Mahdi and my metric number is B031910141. I will be proposing another algorithm that is better than depth first search algorithm. Depth first search, which is also known as DFS, is an algorithm for traversing or searching tree or graph data structures. DFS is using stack, where it will make DFS explore the node branch as far as possible, and the number of ordering will be 2. A better algorithm than this will be the other graph traversal algorithm, which is breadth first search algorithm, which is known as BFS. In comparison, breadth first search can be better than depth first search in several aspects. Breadth first will visit a graph vertex by moving across to all the neighbors of the last visited vertex. It is used queue first in first out. BFS will find the shortest path between the starting point and any other starting node. Meanwhile, DFS is not necessarily to do this, so the process will be the fast than DFS. But a BFS generally requires more memory than a depth first search. To summarize, breadth first search is better than depth first search. Depth first search pointed to the mentioned aspect. Sometimes depth first search the searching will be take a long time than breadth first search. It is because the depth first search will go through all entire traversal before process it. I guess that's it for me. Thank you.